Imagine facing the devastating aftermath of a heart attack, where your heart's vital muscle is scarred and weakened, but what if a tiny patch could turn the tide, helping your body heal itself more effectively? That's the groundbreaking potential of a new microneedle patch developed by researchers at Texas A&M University, led by Dr. Huang. This innovative device targets the core of heart damage post-attack, delivering healing agents right where they're needed most, and it's sparking excitement in the medical community. But here's where it gets intriguing. Could this localized approach really outperform traditional treatments without unintended side effects? Let's dive in and explore how this patch works, why it matters, and the debates it might ignite. At its heart, pun intended, this biodegradable patch features an array of ultrafine microneedles loaded with tiny particles containing interleukin-4, or IL-4 for short. For those new to the term, IL-4 is a protein that plays a crucial role in regulating the immune system, much like a skilled conductor directing an orchestra of cells to maintain harmony in the body. When applied to the surface of the heart, these needles gently dissolve, releasing IL-4 directly into the injured areas. This targeted delivery fosters an environment conducive to recovery, minimizing any spillover effects on other parts of the body, a smart design that avoids the one-size-fits-all pitfalls of broader treatments. Dr. Huang, an assistant professor in the Department of Pharmaceutical Sciences, described it vividly. This patch acts like a bridge. He explained how the microneedles pierce the heart's outer layer, enabling the drug to reach the underlying damaged muscle, which is typically challenging to access. The team's findings were published in Cell Biomaterials, supported by funding from the National Institutes of Health and the American Heart Association. It's a collaboration that underscores the blend of engineering and biology in modern medicine. To understand the patch's importance, it's essential to grasp what happens after a heart attack. Picture this: during an attack, the heart's muscle cells are starved of oxygen and essential nutrients, leading to widespread cell death. In response, the body instinctively forms scar tissue around the damaged zone. While this scarring provides structural support, think of it as a makeshift bandage, it lacks the elasticity and contracting power of healthy muscle. Consequently, the surviving heart tissue has to overcompensate, pumping harder and risking eventual heart failure. This progression is like a chain reaction where one weak link weakens the whole system, and for beginners, it's why heart attack survivors often face lifelong challenges in maintaining cardiac health. Huang's team believes their patch could break this cycle. By delivering IL-4 precisely to the injury site, it influences immune cells called macrophages, the body's frontline responders. Normally, macrophages might amplify inflammation, exacerbating damage, but IL-4 helps reprogram them into healers. This shift reduces excessive scarring and promotes better long-term healing. Macrophages are the key, Huang noted. They can either make inflammation worse or help the heart heal. IL-4 helps turn them into helpers. It's a fascinating example of how tweaking immune responses can tip the scales toward recovery, similar to how coaching a team to focus on defense can prevent a game from spiraling out of control. And this is the part most people miss: the benefits of localized delivery. Previous efforts to harness IL-4 involved injecting it systemically into the bloodstream, which circulated it everywhere, potentially causing harmful reactions in other organs, like unintended inflammation elsewhere in the body. The patch sidesteps this by concentrating the treatment solely on the heart. Systemic delivery affects the whole body, Huang said. We wanted to target just the heart. For illustration, imagine watering your entire garden to nourish one thirsty plant versus using a precise drip system. The patch is that efficient drip, ensuring resources go exactly where they're most needed without wasting a drop. But here's where it gets controversial. One surprising finding from the study involved unexpected changes in heart muscle cells themselves. Treated cells became more attuned to signals from neighboring tissues, especially endothelial cells, those that line blood vessels, acting like the walls of highways for blood flow. This enhanced conversation among cells could bolster recovery over time. The cardiomyocytes weren't just surviving, they were interacting with other cells in ways that support recovery, Huang said. Additionally, the patch dampened inflammatory signals from endothelial cells, which might otherwise worsen damage, and boosted activity in the NPR1 pathway, known for promoting healthier blood vessels and overall heart performance. Critics might argue this sounds too good to be true. Is the body really capable of such dramatic reprogramming, or could this lead to unforeseen complications down the line? It's a point worth debating. Does intervening so directly in cellular communication risk disrupting natural processes, or is it a necessary leap forward in personalized medicine? Looking ahead, the team envisions future patches that are less invasive. Currently, application requires open chest surgery, but Huang dreams of a version deployable via a catheter, a thin tube threaded through blood vessels, making it more accessible in hospitals. This is just the beginning, he remarked. We've proven the concept. Now we want to optimize the design and delivery. To advance this, he's teaming up with Xiaoqing, Jade, Wang, an assistant professor of statistics in the College of Arts and Sciences, to build an AI model. This model will analyze immune responses, potentially guiding even smarter therapeutic strategies, much like how data analytics refine sports plays based on past performances. In summary, this microneedle patch represents a beacon of hope for heart attack patients, offering targeted healing that could redefine recovery protocols. Yet, as with any emerging technology, it raises eyebrows. Is localized delivery the ultimate solution, or might it overlook broader systemic factors in heart health? Could ethicists worry about artificially altering immune behaviors, potentially paving the way for over-reliance on such interventions? We invite you to share your thoughts. Do you think this patch is a game-changer, or are there risks we're overlooking? Agree or disagree in the comments below. Your insights could fuel the conversation. This material is based on a point-in-time release from the originating organization and authors, edited for clarity, style, and depth to enhance understanding. Mirage News remains neutral and does not endorse any institutional views. All opinions and conclusions are solely those of the authors. For the full original article, visit https://www.miragenews.com/microneedle-patch-boosts-heart-attack-recovery-1575423/.